1. W plus 7 equals 357. What value of W is the solution to the given equation? This is, I'm so used to writing X, I wrote an X. This is going to be just an algebraic equation. We don't have to do anything super fancy here. So W plus 7 equals 357. When we are solving for a variable in an algebraic equation, we want to undo what's been done to it by doing the opposite. Here, 7 has been added to W, so to solve for W, we need to do the opposite. The opposite of adding is subtracting. So I'm going to subtract 7 from both sides. When there's an equal sign, we have to keep it equal. We have to do the same thing to both sides, always. So on the left, W plus 7 minus 7, those cancel out, and we're just left with W. And on the right, 357 minus 7 is 350. And that is B. B is my answer. Number 2, which expression is equivalent to 16 times x plus 15? This is testing your knowledge of the distributive property. When I have a number that is in the front of a parentheses, it is the same as that number multiplied by each individual thing inside the parentheses. This is true whether there are two terms within the parentheses or 25 million. It doesn't matter. You would do the same process. So let's do this one by one. 16 times the first term, 16 times x is 16x. And 16 times the second term, which is positive 15, that plus or minus goes with it. So 16 times positive 15 is positive 240. 16x plus 240 is my answer, and that is B. If you'll notice in this one, all 4 of the answers start with 16x. They're being nice. That doesn't always happen. That's not always the case. I might have looked over there and I might have seen 32x plus 480. They like doing stuff like that, where after you distribute, it doesn't match exactly with one of the given answers, in which case you're still looking for something that's equivalent. So what I would do in that case, which does happen, again, not on this problem, but it does happen on the SAT in general, that's why I'm telling you, you look over here at the answers that are given and you see if any of them can have a greatest common factor that you pull out. And after you simplify it, it should look like your original one. Conversely, you can take this and multiply it by several factors and see if it matches any of the answers. So that's something to look out for in this type of problem. But again, for this particular problem, it is more straightforward and it is just B. Number 3, the table summarizes members of a local organization by age and whether they live east or west of the river. If a member of the organization is selected at random, what is the probability that the selected member is at least 40 years old? These types of charts, these tables, have multiple tallies, multiple totals. They're adding in each direction. So this line is being added and totaled here. This line being added and totaled here. The same thing is happening vertically. This column is being added and totaled here. This column is being added and totaled here. So if you want the total for any of these categories, you look at the end of that row or column. This number in the bottom right corner, the column bottom right corner, is the grand total of people who were interviewed, who were asked their age or where they lived. So the numbers this way will add to this corner number, and the numbers going down will add to this corner number, both ways. That's how we read this. So here they're asking us, what is the probability, if a member is selected at random, what is the probability that the selected member is at least 40 years old? So here is my at least 40 years old row, and the total people that are at least 400 years old, 40 years old are 107. Where that came from. Now, if we want to know the probability, we want the part out of the whole. So the part was the members who are at least 40 years old. That's 107. The whole is the total number of members in the entire organization. And again, that's always going to be that bottom right number in this kind of chart. So my whole number is 135. 107 out of 135. That is the probability of that, and that is D. 107 out of 135. D is my answer. Number 4. 3x equals 12 and negative 3x plus y equals negative 6. The solution to the given system of equations is x, y. What is the value of y? Can you solve this by graphing? Yes. Would I recommend you solve it by graphing? No. Here is why. And again, this is not to shame anyone who chooses to solve it by graphing. We want to have the ultimate goal of getting the most right answers, right? So, if you're looking at a problem and you are not confident in your ability to do it longhand, or you think it will take too much time to do it longhand, by all means, do graphing. In some cases, it is absolutely the right choice for everyone. In a case like this, if you are very familiar with substitution or elimination, those alternate methods of solving system of equations, it will probably be faster for you to do it that way than to do graphing. And here's why I say that. So 3x plus 12 and negative 3x plus y equals negative 6. And they're wanting to know why. So when I look at this, I look and see, could I easily, quickly do substitution or elimination? And I see right off the bat, I see a negative 3x and a positive 3x. If I were to do elimination, that is, if I were to add these together and trying to eliminate one of the variables, I don't have to multiply by anything. I don't have to do anything. If I add them together, those 3x's are going to cancel right out. I'm going to be left with a y, a single y, and that's what I want to know. I want to know the value of y. So to me, when I look at that, I go, wait a minute, those x's cancel right out. So if I were to add this together, 3x plus negative 3x is just 0. I'm just left with y on the left. And 12 plus negative 6 is 6. I've got my answer. Y equals 6. This is why practice is helpful. Because if things like this, if I can do that more quickly than typing that into a graphing calculator and then looking for the point, where the lines intersect, that's what you do. If there's lines, you're going to look for that single point of crossing if it exists. Some lines are parallel. They will never cross. Some lines will be right on top of each other. They are all solutions. Those are the other two possibilities, in case you were wondering. I mean, again, like I said, there's no shame in that. If that's the way that you need to do it to solve this answer, then that's the way you need to do it. Then that's the right way for you. But if we practice a lot and get faster at these other ways of doing these kind of problems, then we'll have options. And we can choose which one is the best and fastest fit for that particular problem. So for here, our answer, the value of y, is B, 6. Number 5, a line in the xy plane has a slope of 1/9 and passes through the point 0, 14. Which equation represents this line? This one is the best way to solve this problem is using our knowledge of the slope-intercept form of a line. That's y equals mx plus b. In this slope-intercept form of the line, it's called that because m is my slope. It is a constant, that means a number. And b is my y-intercept, and that's another constant. And the x and y are the variables. So they're telling us it has a slope of 1/9. It's like, okay, m is my slope. I'm told it's a slope of 1/9, so I'm going to replace that m with 1/9. And it passes through the point 0, 14. Well, on the xy plane, everywhere on the y-axis, the x value is 0. So the y-intercept of a line will always have an x value of 0. So by giving us this ordered pair, these coordinates of 0, 14, they're telling us the y-intercept is 14. So I'm going to plug that in here in my equation. The y-intercept, I'm going to plug in 14. And now I have my line. That's it. I have my equation of the line. Y equals 1/9 x plus 14. And I go over here and look, and the one that matches that is right here. And as you can see, they aren't really trying to trick you with your slope-intercept form of the line? A lot of times they do. A lot of times they provide decoy answers, answers that are trying to pull you down a different path. Before I looked at the answers, I would have expected one of them to be like y equals 14x plus y 1/9, switching that slope and y-intercept to try to get you to go the wrong way. But that's not what they did. Here they were mostly focused on the negative and positive. So they have 2 with a negative slope, 2 with a positive, and then they have 2 with negative y-intercepts and 2 with the positive y-intercepts. So the slope and the y-intercept in this case are just what you see is what you get. So 0, 14, it's a positive number. Then that y-intercept is going to be positive. And here that's a positive slope. So you want the positive slope. And there's one with both of them. Y equals 1/9 x plus 14. D is your answer. Number 6. Note figure not drawn to scale. In the figure shown, line C intersects parallel lines S and T. What is the value of x? Anytime you see this figure not drawn to scale, all they're saying is you can't just eyeball it and take a guess and expect it to be right. It's going to be pretty close to what it looks like, but it's not exact. And that sort of taking a guess is what they want you to avoid. You're like, well, it looks like it's 45 degrees or 50 degrees, so that's my answer. We can't do that. So we have to go just by what they've told us. And what have they told us? That lines S and T are parallel. These are parallel lines, which means this other line C that intersects them is what we would call a transversal. That's how you're going to see it in your math book, as parallel lines crossed by a transversal. It's just a line that goes straight across both parallel lines. When this happens, it sets up 2 intersections. We have the one right here and the one right there. It's always going to do this. It's always going to create 2 intersections. Those 2 intersections match. They are identical. That is really all you need to know for the SAT. Not for geometry class. For geometry class, it's something different. So I'm going to just draw it again over here. Let's say I have my 2 parallel lines, and I'm going to have a transversal. I'm going to have it going this way. Same thing. I have 2 intersections. Those intersections are identical. The angles within them are identical. So that means this angle is the same as that angle. It means that this angle is the same as that angle. Now, if you know from your geometry class that opposite or vertical angles are congruent, that means these 2 angles are congruent. So this angle is the same as that angle. Same over here. Those are vertical or opposite angles. So this angle and that angle are congruent. And we're going to do the same in the other direction, which means those 2 angles and those 2 angles. So they are matching. We have 2 pairs of matching angles in these 2 matching intersections. Now, in your geometry class, you have to know the names for all these relationships. It's things like same side interior angles or same side exterior angles. Or I think opposite, forgive me if I got that wrong, so opposite or alternating. I sometimes mix them up. Exterior angles. You have to know all those things for a geometry class. You do not have to know those names for the SAT. This is what I've shown you right here, that these match is what you have to know for the SAT. And one little additional fact is that you see how my red and my purple lines, my angles here, my red and purple angles here, they form a line. They can form a line that way. Red and purple form a line that way. Red and purple form a line that way. Red and purple form a line that way. Anytime I have 2 angles that form a line, you add them together, you're going to get 180 degrees. So that another way of saying that is they are supplementary. They add up to 180 degrees. So all my red angles in my little drawing here and all my purple angles, the reds and the purples are supplementary. They will add up to 180 degrees no matter where you pull them from. So this angle right here plus this angle right here, that's a red and a purple, they will add up to 180 degrees. All the reds are congruent to each other, all the purples are congruent to each other, and the reds and the purples add up to 180 degrees no matter where you pull them from. With all that in mind, again, that's all you need for the SAT. You do not need to know the names of them. we are given this thing where we have line C crossing the parallel lines S and T. This one, I'm going to draw it, make this a blue and a blue. That matches this blue and blue. And let's get like a, yeah, let's go green. We don't have any green. All right, so green and green matches. I'm trying to make these a little thicker so they stand out more. Green and green. Okay. Excuse me. So this 110, that's right there. We know that this up here, that's a matching one. That's 110. And now that blue and the green, X is a green. And we can see too, they're forming a line. So 110 plus that X is going to equal 180 degrees. They're supplementary. We know that because of this rule, and we also know it because they're forming a line. So if 110 plus X equals 180, then to solve for X, I need to subtract 110. I'm doing the opposite. Since 110 is being added, now I'm subtracting, doing the opposite. And when I do that to both sides, I am left with X on the left and 180 minus 110, or 70 on the right. So X is 70. And that is my answer. And I'm just going to put that in. I do not put in the degree. There's no real way to do that. So we just put in 70. Do not worry about putting the degree in for your answer. But yeah, this little chart up here, if you know this little chart, if you know what it means, and you know that the corresponding, the colors, how they match up, and that opposite colors, no matter where they're from, add up to 180, you'll be able to answer any of these questions that show up on the SAT. Number 7, f of x equals x plus 8/11. The function f is defined by the given equation. What is the value of f of x when x equals 3/11? This is a question testing your ability to evaluate a function. When we have a function, whatever it may be, let's say it's just f of x equals, x minus 2. Then they want to know what is f of 3. All they're saying is, okay, when my x is 3, what happens when I do the math? So everywhere there's an x on the other side of the equation, in this particular function, it's only there one time. Everywhere there's an x, you plug in this number. So there's a single x right there. I plug in 3 for that. 3 minus 2 is 1. So f of 3 is 1. That is what it means to evaluate a function. It is you plug in the number that's provided and you do the math. So here we have f of x equals x plus 8/11. And then it said, what is the value of f of x? What happens when you do the math? When x is equal to 3/11. Another way of saying this is, what is f of 3/11? It may be presented either one of these two ways on the SAT. So x is 3/11. Everywhere there is an x, there's only one in this case. We're going to plug in that 3/11. So 3/11 plus 8/11. When we add fractions, we're saying how many of this size of thing? How many 11ths of a thing do I have? I have 3 of them. I'm adding 8 more 11ths of a thing. I took a thing, I divided it into 11 parts. I took 3 of those parts. I add 8 more of those parts. How many parts do I have? I have 11 of those parts. I have 11 11ths. 11 11ths can be simplified because it's another way of looking at it is 11 divided by 11, and that is just 1. So the value of f of x, what it is we get when we do the math, when x is 3/11, is just 1. That is my answer. Number 8. The table shows 3 values of x and their corresponding values of y. There is a linear relationship between x and y. Which of the following equations represents this relationship? A linear relationship between this set of values, it just means if I chart these 3 numbers on a graph, and I'm not sure exactly where they're going to be, I'm just putting 3 dots to illustrate the point. If I put them on the graph and then I draw a line through them, that's a perfectly straight line. That's the visual version of that. The equation version says that I can create an equation, usually given in the form y equals mx plus b, and all these 3 numbers these three sets of numbers, I should say, will fit into this. They'll make the equation true. This form right here is called the slope-intercept form of a line. It's the most common form of a line. It's called that because the m here is going to be just a number, and that number will be your slope. The b is also a number, and that's going to be your y-intercept. And if you look at our answers, all four of them are in this format. Y equals, and then everything else is on the right-hand side. So what they're telling us is we need to figure out what the slope and the y-intercept is for this line. If we're talking about the y-intercept visually, it's just going to be where a line crosses the y-axis. That's it. If we're talking about where that is, if we're looking at the numbers, any point that's on the y-axis, that x value is going to be 0. So let's look at our chart over here, and sure enough, there is one where the x value is 0. So when x is 0, y is 18. That means it's going up near here somewhere, not drawn to scale, but that's going to be my y-intercept, 18. So I can get rid of that b and replace it with 18. That's my y-intercept. Next is the slope. Slope is often defined as change in y over change in x. Or you might see it in your math book as y2 minus y1 over x2 minus x1. All this is telling you to do, even though it looks very fancy, is to take 2 points and plug them in. We say 2 points. Each of these up here is a point. X, Y, X, Y, X, Y. I can pick any 2 of these that I want. Now I'm going to color code it to make it a little easier to see. I'm going to pick this first one. I'm going to write it in green. I'm going to pick the third one, and let's make it baby blue. All right, so baby blue. All right, so the first one, 18 and 0. That's going to be my first point, green. So the 18, the y, goes on top. The 0, the x, goes on the bottom. And I'm going to be subtracting, because that's what my formula says. Then I take the second point. The second point is 8 for the y, 2 is for the x. So 8, that y, goes on the top, and 2, the x, goes on the bottom. Now I just subtract. 18 minus 8 is 10. 0 minus 2 is negative 2. I can simplify that. 10 divided by negative 2 is negative 5. Negative 5 is my slope. No matter which points you do, and which point you decide to use as your first point and which one you decide to use as your second, you are always going to get negative 5. Always. I promise. So I can go up here and replace that slope, that m, with my real slope, negative 5. And I have an equation there. Y equals negative 5x plus 18. And down there, D, you can see that's my option. If we look at the answers that they were giving, we had 2 possible y-intercepts. We had that 13, and we had an 18, and there were 2 possible slopes. We had a pair that were negative 5 and a pair that were 18. So sometimes they will do things a little different. They might put it in standard form, which is where you have, your x and your y on the same side, usually with numbers in front of them. They aren't doing anything mean like that here. They're just using slope-intercept. So again, D, y equals negative 5x plus 18 is my answer. Number 9, x plus 7 equals 10 and x plus 7 squared equals y. Which ordered pair xy is a solution to the given system of equations? The first thing people tend to ask on these sort of questions is, can I solve this by graphing? Yes, you can. Do I recommend it? Not really. Trust me, if there's one where it's absolutely an advantage to do it by graphing, I will tell you. If you do choose to do it by graphing, that's totally fine, of course. This is all in service of your highest score. If you think that you are more confident with the graphing and that it will be faster for you to do it that way, go for it. Absolutely. If you do choose to do it by graphing, you're going to be looking at a parabola, and there's going to be a line intersecting it somehow. And you're going to look for the points where they cross. Those will be the solutions to the system of equations. Now, why do I say I don't recommend it? In this particular case, if we've practiced, if we know our methodologies, our methods of doing these problems, I think it's actually faster to do it without graphing. First reason why I say that, look at our answers over here. When we glance at those answers, you might notice, stands out, I think, that x's are given to us because every answer has 3 as the x. So we don't need to worry about solving for x. It's already done. All we need is to solve for y. Well, if I look over here at what I'm given, I'm told that y is equal to x plus 7 squared. Well, what is x plus 7? We're told what x plus 7 is. It's 10. So y is equal to 10 squared. 10 squared, 10 times 10 is 100. So y is 100. And there's my answer. A, 3 100. Personally, I think that is faster than graphing, if we recognize that. Now, and again, the things that contributed to me and that I would look for in systems of equations going forward is, do things match? Like here I saw an x plus 7 and an x plus 7. So immediately I'm like, is there going to be an easy way to connect these two? In this case, also because this top system and this top equation in the system of equations doesn't have a y. It only has an x. So if we had needed to solve for x, we very easily could because, it's just an x. It's just a solve for x situation where we would subtract 7 from both sides and we would get that x is equal to 10 minus 7 or 3. But we didn't even have to do that because they gave us the 3. Knowing how to do these sort of things is very important on the SAT. On this particular problem, like I said, you absolutely could have graphed. That is an option, and that's totally fine. But knowing how to do this, in this case, it's substitution is the method that we're using here. This isn't a traditional substitution in the sense that usually you're isolating one of the variables. Like you're getting x equals blah, 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 and then going to the second equation, and everywhere there's an x, you plug that in for the x. And also there's some system of equation problems that can't be graphed. So knowing these methods has been beneficial. But there's my answer, 3 100. Number 10, the function f is defined by f of x equals 7x minus 84. What is the x-intercept of the graph of y equals f of x in the xy plane? They love using more words than are necessary to make sure that you know what they are talking about. So this part, the graph of y equals f of x in the xy plane, it means that if y is equal to f of x, you can replace this f of x with y. So all that is to say, here is a line. What is the x-intercept, not the y-intercept? A lot of times with these, I would expect there to be a decoy answer among the multiple choice answers that would have the y-intercept. It's not the case here, but it often is, so please be aware of that. The y-intercept is when it is in the form of y equals, this is a slope-intercept form of a line, y equals blah, blah, blah. In this form, the number that is by itself, not the number with the x, the number that's by itself is the y-intercept. So I was expecting there to be over here on the side, let me get my little y back. I was expecting there to be an option here that had that negative 84. Be advised. The x-intercept is going to be where this line crosses the x-axis, wherever that is. Now there are two ways to do this. You can graph it and you look for where it crosses the x-axis, or you can solve it algebraically with numbers. Either of those is fine. For this one, I think it's probably pretty close to the same time either way for most people. Sometimes there's a clear advantage to one over the other, graphing versus doing it by hand. I think it's about the same on this one. So anywhere that is the x-axis, y is equal to 0. Anywhere on there, any of these coordinates, y is going to be 0. And you can see that reflected over here in the answers. The y value is 0 for every single one of those. So even if you didn't remember that fact, if you looked over at those answers and hey, the y is 0 in every single one of these, It gives you a clue as to how to do it with our numbers algebraically. Y is always 0, so what you do is you plug in 0 for the y. And then we want to know what the x value is, so we solve for x. This is just a more straightforward algebraic equation at this point, since we only have one variable, the x. To solve for x, we want to undo what's been done to it. Here, x has been multiplied by 7, and then 84 was subtracted. We go in reverse order. So we get rid of that minus 84 first. We want to do the opposite. We want to add 84. And we need to do that to both sides to keep it fair and balanced. So 84 on the left and 7 times x on the right. Now, 7 times x, we want to undo that. What is the opposite of times? It is division. So, want to divide both sides by 7. This is from our 12 times tables. If you're a little rusty on the 12 times tables, I do not blame you. I often feel a little rusty on those myself. We don't use those as often, and they are a little more awkward, I think, than the other times tables. So 7 goes into 84 12 times. So my x value is 12. My y value is 0. 12, 0 is my x-intercept, and that is D. Again, if you want to type this in to your graphing calculator and then look for the point where it crosses the x-axis, that is an equally valid way to do this. Either way, you get D, 12, 0. Number 11. Rosa opened a savings account at a bank. The table shows the exponential relationship between the time t in years since Rosa opened the account and the total amount in dollars in the account. If Rosa made no additional deposits or withdrawals, which of the following equations best represents the relationship between t and n? This is an interest problem. It's going to use a formula that is pretty much identical to the formula you'd use for an increase in population, like the growth of a animal's population in an area over time, or decrease over time. That's the kind of problem you usually see on the SAT, is populations of animals, bacteria, things like that. Not as much straight interest, but it's the same formula that they want you to use. And it's going to be your principal or your starting number, your starting population, times 1 plus, and then it's going to be the percent increase or decrease, whatever that is. And usually write this as a decimal. Keep things nice and easy. And it's going to be the power of time, how many, the time intervals you're using. So for example, let's say if I had a population of 100 and it increased 5% every month. How long would it be after 6 months? You'd say, okay, my initial is 100. This 1, because I'm going to be multiplying by this, 1 is the initial population, and then we have the percent increase. It's going to be adding because it's an increase, 0.05, and it's every month for 6 months. That's how I'm filling that in. This is a very, very good formula to know. Please memorize it before the SAT. It is not provided, but it comes up all the time. So let's look at our chart and see what would go in here. And we may or may not need to fill in everything. First, what is our P? What is our principal? What's our starting population? Whichever of those terms apply for this problem. In this case, it is our starting principal. Here it says the time in years, 0. The amount is $604. So no time has passed, $604. So that's the amount she put into the bank at the very beginning, before any time has passed, before it's earned interest. So our principal is $604. And it's 1 plus our percent of increase. As we can see, it's going up as the years pass. And it's over the years. Do we need to figure out this percent increase? Before we go down that rabbit hole of trying to figure that out, look over here at our answers. Do you see how only one of them is even possible? And it's C. C is the only one that has a number out in front to represent the principal, and that number is the correct number. The only other one that has a number in front is D, and it's 0.004. That is not her starting amount. It looks like that's going to be the percent or the amount of interest on, the increase of the decimal increase, I can't speak today, of, of her account, but it's not her starting amount. The only one that has a number out in front, and it's the correct number, is C, where 604 is out in front. And you also can see that this one has a 0.004, that one has it, that one has it. And that's the only decimal that's in there. So that's clearly what should be going here if we were going to fill out this whole equation. But we don't even have to do that calculation because, yeah, it's the only one. It's got 604 in front. So that's why knowing this equation, or this original equation, can be so helpful. Not only is it critical to getting the right answer, for some where you have to do the calculations, you have to actually figure out what the population would be at a certain point in time. But for ones like this, because you know this formula, you can just look down and go, wait a minute, that's the only one that has it. It must be C, and you move on your merry way. If you do not have that information, you would probably be stuck with plugging these numbers in to these different equations and seeing which one gets you those answers, which is a valid way to do it. If you forget this, that's a good backup, but it's much quicker for you and less stressful if you can just remember this equation and know that, whoop, C is the only one that has our principal there out in front. C must be our answer. Number 12. W of t equals 300 minus 4t. The function W models the volume of liquid in milliliters in a container t seconds after it begins draining from a hole at the bottom. According to the model, what is the predicted volume in milliliters draining from the container each second? All right, so I'm going to write this over here, and I'm going to sort of identify what everything is here. Okay, so this is going to be the volume in milliliters. All right, t seconds. So this is my number of seconds after a hole starts draining in the bottom. All right, so 4 times t would be how many milliliters? So what do these numbers represent? Let's think about this. Let's see. If it's 0 seconds, nothing has happened yet. Nothing has been, a hole has not been punctured into this container. What would it be? What would it be if I plug in 0 for t? Both these spots. W of 0 would equal 300 minus 4 times 0. 4 times 0 is just 0. So 300 minus 0 would just be 300. So when t is 0, or W of 0, there's two ways we can look at that. So when t is 0, or W of 0, we get 300. So that means that before the hole is punctured, this container has 300 milliliters of liquid in it. So that's my starting. I have this container. It has 300 milliliters of liquid. All right. What happens at the first second? What happens then? Boop, boop, boop. I'm going to get rid of all my little extra greens here. And I got rid of some of my reds too. Let's put them back. Minus 4t. All right, that's my seconds. All right, so what happens after 1 second? Let's plug in 1. 300 minus 4 times that 1 second. 4 times 1 is 4. 300 minus 4 is 296. So it started with 300. Then in 1 second, it went down to 296. How many milliliters drained out? 4 milliliters drained out. It went down by 4. So this number right here, this 4, is representing how many milliliters are draining out every second. Because then if we put a 2 there, it'd be like, 2 times 4, 2 seconds passed. So 2 seconds of 4 milliliters per second. So then 2 times 4, 8 would have drained out in 2 seconds. So that 4 is representing how many milliliters are draining from the container each second. So that is my answer, D, 4. Number 13, h of x equals x plus b. For the linear function h, b is a constant and h of 0 equals 45. What is the value of b? When we're talking about functions, there's certain terminology you need to know. You need to know what they're asking for. So here's what's going on with a function. Most common one is f of x, but as we see here, it can also be things like h of x, g of x. It doesn't matter. F of x is the most common. If I have a function, let's say f of x equals x plus 1, very similar to the one we're dealing with here, what it's wanting you to do is it'll say, what is f of 2? What it means is this x, that's 2. 2 is x. So everywhere in the equation where there's an x, you're going to replace that x with a 2. Then you do the math, and your result is the answer. In this case, 2 plus 1 is 3. So that's how that works. So in this case, we have h of x equals x plus b. We're told that b is a constant. It means it's just a plain number. Just a plain old number. You know, it could be 5, 10, negative 100,000, whatever. It's just a number. Our second piece of information is that h of 0 equals 45. So it says when we plug in 0 for x, so right here, here's our 1x. If I replace that x with 0, and I do that math, I am going to get 45. So if 0 plus b equals 45, we know a number plus 0 is just that number, so 0 plus b is the same as just b. I know that b is 45. And that is my question. The question is, what is the value of b? And there is my answer. B is 45. Number 14, z squared plus 10z minus 24 equals 0. What is one of the solutions to the given equation? Now, usually with this, a lot of students want to go straight to graphing. If you do, that's fine. There's nothing wrong with graphing. If you've done a lot of factoring, then honestly, it might be a little bit faster because this one isn't a overly complicated factoring one. We don't have a negative out front. We don't have, out front, right here. We don't have an extra coefficient there in front of that first squared variable. So as far as factoring goes, it's pretty straightforward. If you want to graph it, totally fine, of course. Do what you know you can get the right answer, and it's going to be the fastest for you. So this one, you might notice it doesn't equal y, it equals 0. So when you graph it, you're going to get straight lines if there are solutions, up to 2. Could be 1, could be no straight lines. But because it equals 0, that's what you're going to get. You're just going to get vertical lines. And those vertical lines are going to be equal to x equals a number. And that number is your solution. Now, because it says one of the solutions, we can assume there are 2 solutions. Yeah, because it's saying, what's one of them? Then it means there's likely to be 2. I don't think they're being that tricky. If side note, if you have a parabola where it's equal to y, and like if this was x squared and x that's equal to y, or we have just 2 variables involved, then the graph you're going to get is going to be a parabola, and you're going to be looking for the places where it crosses the x-axis if those exist. So you're going to do that. You're going to look in, if you're graphing it, and see where those 2 lines are. If you decide to factor it, when you factor something like this, it doesn't have a number, a coefficient in front of that first variable that's squared. It doesn't have a negative in front of it. It is just our very introductory factoring. We don't have to do anything fancy. And what you're looking for is 2 numbers that multiply to get negative 24, but that they add together to get positive 10. So to negative 24, what goes into 24? It's 2 times 12. I always like to start with the lowest one first and go up from there. And then so that could be either negative 2 positive 12 or 2 negative 12. And if you're looking for speed, I say add them as you go. Great. Excellent. And edit. And alarm. Yay. So I'm not going to get this done. That's excellent. Okay. Great. Whatever. This shouldn't have been hard. In 3, 2, 1. With this, because it is a... In 3, 2, 1. With this, because it is, we're wanting for speed, if I was doing this for a class, I would probably go through all of my options. I'd write them all out. And then I'd go through and add them all. But because this is for speed, I'd probably be adding as I went if I'm taking this test. So I would even start up here. I'd be like, okay, first, -2 and 12. -2 plus 12 is 10. Wait a minute, I've already got my answer. You see what I'm saying? Or even if I'd started with 2, -12, I'd be like, -10. Oh, that's really close. I think I just need to reverse the sign. It needs to be -2, +12. All right, 10. Don't have to write out all those factors. Just do them as you go. Once you found the one, we're not being graded on our work here. We're being graded on the answer. So the answer is the key. So, okay, right off the bat, and if I'm adding as I go, I get that it's -2 and 12. So I always write x by default. It's going to be z minus 2 times z plus 12 equals 0. And when we set each of these equal to 0, which is how we solve for factoring, because this times a number equals 0, or this times a number equals 0, one of them has to be 0. When we multiply two things together and get 0, one of those two things must be 0. So here, z minus 2 equals 0. To solve, we add 2 to both sides, and we get z equals 2. Here we subtract 12 from both sides, because we're undoing what's been done to z. So we're just going to get z on the left and -12 on the right. And as you may notice, or you may have already learned this from factoring, when it's not a fancy factoring equation, when there isn't anything in front of this initial squared variable, when it's just straightforward, we're going to get these two equations where my final answer is the opposite of what's in there. So here at z minus 2, my answer is +2. Here at z plus 12, my answer is -12. Again, that's only when there's nothing weird or funky going on and there's nothing in front of the z. There's no negative, there's no coefficient. In front of, I should say, in front of the squared variable, because it could be a z, it could be an x, what have you. So only in that case, it ends up just being the opposite. And that's why I said, if you practice factoring a lot, this may be quicker to do it manually. Because if you've practiced a lot, you wouldn't have to write all that out. And never misinterpret me as saying there's anything wrong with needing to write stuff out. There isn't. And if, that's what you have to do to answer it, of course it's fine. There's nothing wrong with it. There's nothing shameful about writing stuff down. I'm just saying, if you get to that point, if this applies to you, where you've practiced and you've recognized this pattern and you got it solid, and you feel like, oh, I don't need to write it down. You may not. You may get to just this point and just go like, okay, -2 and 12 is 10. I know it's going to be the opposite of those, so it's going to be 2 and -12. But you have practiced a lot and be very confident to be able to go to jump to that. So anyway, those are the methods that you can do. When there's multiple methods, I feel like I'm talking so much because I'm giving you all these different ways of doing it. So I hope that's not adding confusion and making things worse. I apologize if that is not my intention. My two possible solutions are 2 and -12. They're asking what is one of the solutions. Do not put both of them. It'll get it wrong. So just pick one and move forward, and you've got your answer. Number 15. Triangle FGH is similar to triangle JKL, where angle F corresponds to angle J, and angles G and K are right angles. If the sine of F equals 308 over 317, what is the value of sine of J? Right, so they're testing our knowledge of similarity in triangles, and they're testing our knowledge of sine. What is sine? Also related to cosine and tangent are trig identities. So first, similarity. Similarity means I have two triangles and their angles are all the same, but their sides, the lengths of their sides may be different. They are usually different. If they were identical or congruent triangles, they would also be similar, but just because they are similar does not mean they are also congruent. Similar is they have all the same angles. Congruent is they have all the same angles and the same length of sides. So while in similar triangles, their lengths of their sides are not necessarily the same, that would make them, again, congruent, they are proportional. So let's say this is length of this side was 1 and this was 2. You'd multiply by 2 to get from the smaller triangle to the bigger triangle. So then if you said, okay, so this side, length of this side is 3, what is the length of this side? 3 times 2, or 6. So their sides are proportional, their angles are all the same. That's our first concept. Our second concept is sine, cosine, and tangent. These are proportions that are always true of right triangles with certain degree angles. So basically what happened is long time ago, people realized if I have a right triangle, and let's say this is a 30-degree angle and this is a 60-degree angle, and let's say I had a tinier version of this, but it was similar to it in that it also had a 30-degree angle. Looks like 300, but it's 30 degrees. Can't draw tiny zeros, tiny degree marks apparently. And it was also 30 degrees and 60 degrees. That if I measured this side and divided it by that side, I would get the same exact thing as if I took this side and divided it by that side. Proportions are always going to be the same. And they wrote down what those numbers are. If you divide this side by that side, what do you get? They started doing this a long time ago, and now we don't have to use charts or things like they used to back in the good old days, the ancient days of 20 or 30 years ago, where they had to actually, I'd say more like 40, 50 years ago, but anyway, where they had to look at charts. Now we have it in our calculator. Okay, so here are what the different proportions are. If I want to know what the sine of this angle is, like in this case, the sine of 30 degrees, the sine of this angle, the sine of angle A, I could express it either way. It's going to be the length of this opposite side divided by the hypotenuse. That is sine, and that's what this particular problem is testing. The other two ones they will test, I started to write C there, and I shouldn't. Let's just make that an A. There we go. Adjacent. Cosine is adjacent divided by hypotenuse, and tangent is the length of the opposite side divided by the adjacent. For whatever angle we're talking about, the opposite side is the one it's looking at, like it's seated opposite it at the table. The side that's touching it is the one that's adjacent, like if someone's next to you at the table where you're sitting, they're adjacent to you. And the hypotenuse is always the longest side. I do recommend putting these in your memory bank. They come up a lot. So here, this is our core concepts we need to know for this problem. Now let's look at the problem itself. We have triangle FGH, and it is similar to JKL. We don't know which one is bigger or smaller. It really doesn't matter. We just know these are two triangles. That's a sad little triangle I drew right there. And they are similar to each other. Okay, so we're told angles G and K are right angles. So those are my G and my K. And F corresponds to J. So I've got F up here at top. That means J is up here at the top. And the leftovers are H and L. So I have triangle FGH. And I have triangle JKL. All right, so far so good. The sine of F, sine of angle F, is equal to 308 divided by 317. Does this mean 100% that, because this is representing opposite over hypotenuse, does that mean 100% that the length of this side is 308 centimeters, inches, whatever, and that the length of the hypotenuse is 317? No, it doesn't. It means that's the proportion. That's the ratio. It could be twice as big. It could be 616 and 634. 2 times 308, 2 times 317. The length of these sides does not matter. What matters is this proportion. The proportion of this angle F. So this angle, whatever measure it is, every other angle in every other right triangle in the universe, if that angle is the same measure, it will have the same sign. That proportion is always identical. So when we look over here They're wanting to know what's the value of the sine of j. J is the same measure. F and J, they correspond to each other, so they are congruent. The corresponding angles of similar triangles are congruent. That's when they say corresponds. That's what they're telling us. They're the same. So since the sine of F is this proportion, this fraction, the sine of J is also that proportion. If the measures of the angles, and they're both in a right triangle, if the measures of those angles are identical, and they are, then the sines of those angles will also be identical. The cosines of those angles will be identical. The tangents of those angles will be identical. So, the sine of F is 308 over 17. The sine of J is also 308 over 17. There are variations on this type of problem where they are a little more tricky, where they'll say, if the sine of F is this, then what is the cosine of, and they'll name a different angle. Maybe F, maybe J, maybe L, what have you. So that is possible. That's why I recommend knowing cosine and tangent and being aware how they work together. I also recommend reading these very closely and making sure you're looking at the right thing. In this case, they are both sine. They are both the same corresponding angles, so it is identical. Our answer is B, 308 over 317. Number 16. The population of Greenville increased by 7% from 2015 to 2016. If the 2016 population is K times the 2015 population, what is the value of K? All right, so from 2015 to 2016, it went up, it increased by 7%. The number is 7% greater. So we're saying 2016 is, right, when we see is in a word problem, a lot of times that's where an equal signs go. Equal sign goes. So my 2016, I'm going to write it as an equation. The 2016 population is K times the 2015 population. What is K? So what do I need to multiply that 2015 population by to get to the 2016 population? And look at my answers. Look at these and think of them in terms of percent, because we're told it increased by 7%. So what do all these represent? This is 7/100ths, which is the same as 7%. That's my first option. My second one, 0.7, is the same as 0.70 or 70/100ths, which is 70%. Percent is hundredths. Our third one is 1.07, which is 107 hundredths, or 107%. And then our last one, 1.7, is 170 hundredths, or 170%. So which of these numbers could I insert into here and get this increase? I'm going to think about this two different ways, one using variables and one using real numbers. So I'm going to start with the real numbers. Let's say that the population in 2015 was 100. If it increased by 7%, that means you take 7% of 100 and add it to that 100. So we can say it's 100 plus 7% of 100. All right? So 7% of 100, I'm going to zoom out, give myself a little more room here. 7% of 100 is 7. So 100 plus 7 is 107. And we get 7% of 100, in case this is a reminder here, we multiply 100 times 7%, which is 0.07. So 100 times 0.07 is how we calculate 7% of 100. All right, so I know my 2015 population, I said it was 100. My 2016 population is 107. So I'm going to go down here and I'm going to plug those numbers in. My 2016 population is 107. My 2015 population is 100. So if I want to solve for k, it's k times 100. So I need to divide by 100. I need to undo that, what's been done to k. So I'm going to divide by 100 on each side. I just have k on the right and on the left. 107 divided by 100 is 1.07. And that is my answer. That's C. Okay, k is 1.07. Another way you can look at this, and neither of these ways is right or wrong. If you are in a math class, a teacher is likely going to tell you which of these ways to use. Like, no, you can't use real numbers. You have to use variables. You have to do it this way. You have to do it that way. The SAT, it doesn't matter how you get the answer. Aside from cheating, obviously. I'm not saying cheating's okay. Come on. Come on. I feel like I'm like, as soon as I said that, I'm like, oh, I think someone could put words in my mouth for that. It means if we use real numbers, if we use variables, if we use our graphing calculator to do calculations, any of these methods is acceptable. We do not have to show our work. We are not counted on how we got to the answer if it was done a proper method. Okay, so we know 1.07 is our answer. Let's look at this. And actually, I'm going to go back and we'll do the same sort of thing of 2016 population and 2015 population. And I think understanding this is important because sometimes it's not the easiest thing to plug in real numbers for it. All right, so let's go back and look at the top. It was 100 plus 7% of 100, or 100 times 0.07. What if I didn't know the population? I didn't know what it was. It was an unknown. That's going to be, I'm going to refer to this population, it's the unknown, as x. 1x. Then what is 7% of that? What is 7% of x? X times 0.07, or 0, erase that, 0.07x. And if I add those together, I get 1.07x. Leave that there. Okay. 1.07x. Remember that x is the population in 2015. I'm representing that by x. So the population in 2016 is that original population plus 7% of the population. There's where that 1.07 comes from. It is 100% of the original population plus 7% more. That is 107%, which if we write that as a decimal is 1.07. That's where that comes from. And that's why it works every single time, regardless of what that starting population is. And you can even look at it, again, if you looked at it in another way here, saying if my 2015 population is X and my 2016 population is 1.07 times X, okay, down here, my 2015 population is X and my 2016 population is 1.07 times X. What is K? I divide both sides by X, since X is being multiplied on both sides. And what am I left with? 1.07 equals K. Okay, so that's the math that's going on. So if you are familiar enough with how percentages work, that you can do it in one of these methods, either by plugging stuff in and solving for K, or by just looking up here and going, okay, it's 100% of the 2015. Let me kind of write that under there, make this a little clearer. So if it's, there we go. If it's 100% of that 2015 population plus 7% more to get to the 2016 population is 107% of the original population, or 1.07 times that original population. However you want to look at this, however you get to the right answer, use what makes the most sense. The answer is C, 1.07. Number 17. Each of the dot plots shown represents the number of glue sticks brought in by each student for two classes, Class A and Class B. Which statement best compares the standard deviations of the numbers of glue sticks brought in by each student for these two classes? Okay, so standard deviation is how far away the data points are from the average. So for a visual representation of that, here we go. This one on the left, the average, anytime you have a symmetrical set of data points, the shape is symmetrical, the same pattern is going left and right from that center point. Anytime that happens, and these are all the same distance apart, like 1 apart, 2 apart, whatever, that central point is the average. Always. It's just how it works out. So that's when it's symmetrical. When that happens, that's our average. That's our average. Okay. So here's what standard deviation is. On the left, these points, there's more points that are further away from the middle. On this one, on the right, more are in the middle, and there's fewer points that are far away from the middle. So which one is higher, which one is lower? On the left, this has a higher standard deviation. They are deviating more. That's what the word is. Deviation, coming from or related to deviate. Deviate is when you're going away from the path. You're going away from sort of the way you're supposed to go, shall we say. So you're deviating from it. You're doing something different. So our mean here is the norm, as it were. And here more points are deviating from it. So it has a higher standard deviation. This one, more are staying close to the middle. Fewer are deviating, so it has a lower standard deviation. Now look at our picture up here on the left. Let's look at this. These shapes are identical. We have the same shape, the exact same number of dots above, each number in this sequence. Does it matter that the numbers are different? It does not. They are all 1 apart. That's it. 1, 2, 3, 4, 5, 6, 7. Each of these is 1 apart. 14, 15, 16, etc. 1 apart. That's all that, we have to see. Like, okay, they're the same number of steps and the same number of dots are present here. Do we have to do the mean? Do we have to find the average? We do not. Just knowing that each of these has 7 steps, and that the first step has 1, second step has 1, the third step has 3, first step has 1, second step has 1, third step has 3, etc. That the steps are all the same, and that each of these steps is the same distance apart from each other. They're going to have the same standard deviation. Wherever that average is, and I'm thinking it's probably going to be about there somewhere. Let's see. When I do this math, I'm guessing, I just feel like it's going to be between 5 and 6. I'm going to do the math afterwards and then put that up on the screen right now and see how right or wrong I was. But I'm guessing it's going to be about there. So let's assume that I got that right. Then this one's going to be about there somewhere. It's going to be at the same point relative on the number line. The dots are going to relate and deviate from that point the same because the shape of these dot plots is the same. So the standard deviation for these two dot plots is the same, and that is B. They are equal. And you will never have to calculate what that standard deviation is. And honestly, you shouldn't have to calculate the mean either. I think maybe I've seen one time where they had a table where they actually had numbers in the table and ask you the standard deviation between the tables. I'm thinking that's happened, but this type of thing is far more common, where they show you a dot plot. And the two types of dot plot I've seen are ones like this. Wow, that's a wonky rectangle. They are ones like this, where the shape of the dot plots is identical and the numbers at the bottom are different, and they're trying to trick you with that and say, oh, those numbers are more, so that must be more. Nope. Numbers are the same. The separation between the numbers at the bottom, the dot plots, are the same. The separation between the numbers at the bottom is the same. Standard deviation is the same. And the other variation looks like this that I have here on the right, where you have two sets where the numbers let's say, will be identical at the bottom. And they both will be symmetrical. And I didn't do this one with the same number of dots. But let's see if this one has 1, 2, 3, 1, 2, 3. So that's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can go 10, 11, go like that. There we go. So now they have the same number of dots. And they'll say, all right, which one has, the higher or lower? How do they relate to each other? And it's always going to be this kind of thing where one says A is higher, and one says they're equal. One says A is lower, and one says we don't know. That's always your 4 choices. As of the time of the recording of this video, that's how it's always been presented. And then, yeah. So again, identical dot plots, identical jumps, 1, 1, 1, 1, 1, 1, up by 1, up by 1. Those are going to have the same standard deviation. If they are symmetrical, each symmetrical, and the numbers at the bottom are the same, then the one that is more center-based will have the lower standard deviation. The one that has more points on the outside will be the higher standard deviation. It is deviating more from that center point. And that's really all you need to know about standard deviation for the SAT. You know that. You're going to be able to very quickly answer these questions when they throw them at you. And again, this answer for this one is B. Number 18. M of t equals negative 0.0274 times t over 7 squared plus 7.3873 times t over 7 plus 75.032. The function m gives the predicted body mass m of t in kilograms kg of a certain animal t days after it was born in a wildlife reserve where t is less than or equal to 390. Which of the following is the best interpretation of the statement m of 330 is approximately equal to 362 in this context? There is a lot of kind of frills and jazz hands going on with this problem, but at its core, it's a very straightforward question that does not require you to do any math. Even though you have this fancy pants equation up here, you will not have to do any math. It's just testing. Can you read this text? Can you read this verbiage and tell what a function's purpose is? I'm going to give you a much simpler version of this equation so you can see what's going on. What if I did something like this? M of t equals 5t plus 3. And I told you that t represents the number of days after an animal was born, and that if you do the math, m of t, your result will be how much that animal weighs, the mass of that of that animal, in kilograms. So if the animal was 3 days old, it would be m of 3. You would do the math. 3 times 5 is 15, plus 3 is 18. So m of 3 is 18. That means when the animal is 3 days, t is days, 3 days old, m of 3, how much does he weigh in 3 days old? He would be 18 kilograms. That m of 3 would be 18, means that when the animal is 3 days old, they weigh, or they have a mass of, I always say weigh, they have a mass of 18 kilograms. That's it. T represents the number of days, and the result, m of t, or in this case, the number of days being 3, m of 3, that result is the weight of the animal. So the fact that this equation over here is so very fancy with all these lengthy decimals and squares and fractions, it's the same thing. It's saying if I plug in a number for t, t is the number of days, I do the math, I will get the weight, the mass, I keep saying weight, the mass of this animal in kilograms. That's it. That is it. So we don't even really have to look at that equation. We just know m of t equals the number of kilograms for the mass of the animal. All right. So what does m of 330 is approximately equal to 362? What does that mean? That means that 3 looks weird. I'm going to rewrite it. It means that when it's the time is 3:30, the number of days is 3:30. Sorry, I started writing cursive and then I was like, oh, I shouldn't. And then I ended up writing cursive anyway. Days, there we go. When the days is 3:30, then the result of that math, the mass of the animal is 362 kilograms. That's all it means. M of t, t is number of days, m of 330, so 330 is my number of days, is approximately equal to 362. When I do the math, m of t, I get kilograms. 362 is my kilograms. So it means that after 330 days, this animal is approximately 362 kilograms. So let's look at which of these answers represents that. Here, the predicted body mass of the animal was approximately 333 kilograms, 362 days after it was born. It's flipped, so that one's out. They've reversed them. Probably the reverse of that, B, is going to be our answer. Let's read it to be careful and be sure. The predicted body mass of the animal was approximately 362 kilograms, 330 days after it was born. Yep, that looks like our answer, but let's check the others just to be sure there's nothing tricky going on. C, the predicted body mass of the animal was approximately 362 kilograms, 330 over 7 days after it was born. Nope, just a straight 330. And D, the predicted body mass of the animal was approximately 330 over 7 kilograms, 362 days after it was born. Nope. Very straightforward. It's just B. So it didn't matter. This is really just a test of you knowing what a function means and being able to interpret a word problem and not so much doing the math. But my answer there is B. Number 19, triangle XYZ is similar to triangle RST, such that X, Y, and Z correspond to R, S, and T respectively. The measure of angle Z is 20 degrees and 2 times XY equals RS. What is the measure of angle T? Okay. There's more information in here than you need. So I have triangle XYZ. And I'm not really drawing this to scale. I'm just drawing a triangle, X, Y, Z, and I have this other triangle, R, S, T. And I'm really not drawing them to scale. I'm just drawing two similar triangles. And I usually start drawing right at the beginning, before I even read the whole thing. So I may have drawn them incorrectly, but we'll see. So triangle X, Y, Z is similar to triangle R, S, T, and X, Y, and Z correspond to R, S, and T. Okay, so I've oriented them the same way in space so we can see boom, 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 boom. Similar triangles have corresponding angles that are congruent. Their lengths of their sides are proportional. So unless we are given exact information, we're not going to know exactly the lengths of the sides. We'll get there in a second. I'm just, from where we are right now, stopping right here. All I know at that point is that I have these two triangles and that their corresponding angles are the same. They're congruent, and I've marked them on this picture. Okay, let's keep going. The measure of angle Z is 20 degrees. Okay, measure of angle Z is 20 degrees. And 2 times XY equals RS. Okay, so that means that XY is half of this. Because if I multiply this by 2, I get to RS. I multiply XY by 2. Okay, so I know that XY is equal to 1/2 RS. So my RST triangle is twice as big. Do I even need that information though? Spoiler alert, no I don't. Because the question is, what is the measure of angle T? Not anything about the length of the sides, just what's the measure of angle T? Angle T corresponds to angle Z. Angle Z is 20. Angle T is 20. That's it. You do not need to know the lengths of the sides. You do not need to know the ratio, which is what they were giving you here with 2 times XY equals RS. You don't need that. It doesn't affect the angles. They're hoping that you don't know that, and you'll think that you'll either need to take this 20 and either divide it by 2 or multiply it by 2, which is why you've got the 10 and 40 over here as options. And the 2 is just an outlier. The 2 degrees is just an outlier there. But that's what they're hoping, that you will think this is necessary. Like, why would they say it if I don't need it? Because they're trying to trick you. You do not need that information. It is completely unnecessary. All you need to know is that Z corresponds to T. In similar triangles, corresponding angles are the same. So Z and T are the same. They are both 20 degrees. That's all there is to it. Our answer is C. 20. The function f of t equals 60,000 times 2 to the power of t over 410 gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? This type of formula in this setup, man, do they love it on the SAT. And it's talking about growth, which can be like compound interest, that kind of thing. So sometimes you'll see it in connection with compound interest. More often than not, though, it'll be in this sort of situation where it's a number of bacteria. It's a number of deer in a forest. It's a number of trees in a forest. It's a number of people in a city. They love it talking about population increase. And the format you're going to get, this is your format. This first one here, this first number outside is your starting number. How many of the thing you started with. This number in here is going to be your percent increase. And up here, your exponent is going to be having to do with your time. It might be in years, it might be in minutes or seconds, it might be a fraction. But that's the location of the 3 main parts of this equation. You have to have the starting number, the number of things you started with. You have to have how much it's increasing each time, and then how many times you're having that increase. This formula, be familiar with this formula, because they'll give you, they'll often give you something like this, or they'll ask you to create it by giving you these pieces. These 2 variations show up a lot. And like, say, if they give you this equation like that, they might just ask you, what was the starting number of bacteria? What was the percent increase? And if you know this over here, then you'll know where to find those pieces of information very quickly. Okay, so with that sort of housekeeping done, let's look at what they want to know. They want to know, how long does it take for this number of bacteria to double? So we know, because we know our pattern here, that little pattern, that the starting number is 60,000. That's how many bacteria we started with. So if it's going to double, what do we need to multiply 60,000 by to get it to double? We need to multiply that by 2, right? Well, are we multiplying it by 2? Kind of. That 2 is there, but it's 2 to the power of t over 410. What t needs to be there for this just to be 60,000 times 2? 2 to the power of something. I'll put like a little square there. 2 to the power of what equals 2? Because I want it to be 60,000 times 2. 2 to the power of 0? No. 2 to the power of 0 is 1. 2 to the power of 2 is 4. But what about 2 to the power of 1? 2 to the power of 1 is just 2. That's what I want. I want this to be 2 to the power of 1. So do I have that right now? No, I have t over 410. I want t over 410 to be equal to 1. And they're wanting us to solve for t. What does t need to be for this all to work? Well, any number, I can do this 2 ways. I can just look at it and use what I know about math, or I can do it algebraically. First, I am just going to look at it and say what I know about math. Go, for a number to be divided by 410 and equal 1, it has to be the same number, right? Like 5 divided by 5 is 1. 10 divided by 10 is 1. So t must be 410. So 410 divided by 410 is 1. So if I plug that in there, I get 410 over 410 is 1. Scribble that out and just get 1. Then I have 2 to the power of 1, which is just 2, and I get my 60,000 times 2 like I wanted. So my answer is that T is 410. And if you wanted to look at this algebraically for my initial, it's not letting me, it did not let me highlight and move. It moved the whole screen. If I wanted to do this algebraically, I would say T is being divided by 410. So to undo that, I need to multiply both sides by 410. So on the left, I get T, and on the right, 1 times 410 is 410. Either way, same difference. 410 minutes after the initial observation is when this bacteria population doubles. And that's my answer, 410. Number 21. The function f is defined by f of x equals a to the power of x plus b, where a and b are constants and a is greater than 0. In the xy plane, the graph of y equals f of x has a y-intercept at 0, negative 25, and passes through the point 2, 23. What is the value of a plus b? All right, so this is a good example of a question where we really need to know how to do our stuff. There isn't a sort of thing where we can just plug it into a graphing calculator and have it show us the answer. We need to know what's going on here. So let's start with our first function, f of x equals a to the power of x plus b. And it's saying we can graph this when y equals f of x. Okay, so it's just saying if I were to put this in as y equals a to the power of x plus b, these two ordered pairs make it true, 0, negative 25, and 2, 23. Well, I have two constants here, so I want to solve them one at a time. Which of these can I solve by using one of these ordered pairs? Well, anytime there's a 0, I'm intrigued. Zeros have a way of getting rid of things or making things easier when we plug them into equations. So I'm going to plug in a 0 into this equation and see what happens here. So 0 would be my x, and negative 25 would be my y. So does this help me? Oh boy, does it ever. Because even though I still have two constants here that I need to solve for, a and b, what is any number to the power of 0? It's 1. So a to the power of 0 is just 1. So I've gotten rid of one of those variables, or those variables which represent a constant in this case. So I've gotten rid of one of them because I cannot have two variables that I need to solve for in a single equation and do it. I have to get rid of one of them. If I want to, if you want to solve a set of equations, a system of equations, you have to have, in most cases, if you don't have those ordered pairs, you have to have one equation for every variable. So if you have 3 variables you're solving for, you have to have at least 3 equations. It's just how it works. Except when they do things like this and they give you a handy-dandy ordered pair with 0 in it. So negative 25 equals 1 plus b. Let's solve for b. I'm going to do that by undoing what's been done to b. b has had 1 added to it. I'm going to do the opposite, so I'm going to subtract. I do it on both sides to keep it nice and balanced and equal. Negative 25 minus 1 is negative 26. And then I am just left with b on the right-hand side. Like, great, I now know that b is negative 26. But my final end goal is to determine the value of a plus b, so I need to solve for a. Well, now I've got my b, that is negative 26. So I'm going to start with this same equation again, and we're going to plug things in that we know using the second ordered pair, 2 and 23. All right, so let's plug in everything. My x value is 2. I'm going to put that right there, a to the power of 2. My y value is 23. I erase the y and replace that. And finally, my b is negative 26. So there we go. All right. So I want to solve for a. I just have now a sort of straightforward single variable equation that I'm solving for. I want to undo what's been done to a. Since a has been squared and then 26 subtracted, I want to go backwards and undo that. I'm going to do the opposite by adding 26 to both sides. Always both sides with algebra to keep it nice and balanced. So on the left, 23 plus 26 is 49, and that equals a squared because the minus 26 plus 26 cancels out. Now to undo that square, I'm going to take the square root of both sides. So I have the square root of 49 is plus or minus 7, and that is equal to a. So which is my value of a? How do I know? Well, I know because they told me up here that a is greater than 0. So I know it is the positive 7, not the negative 7. So a is equal to positive 7. And now finally I can get my answer. They want to know what is a plus b. Negative 26 plus 7 is negative 19. And that is my answer. Number 22. Y is greater than 13x minus 18. For which of the following tables are all the values of x and their corresponding values of y solutions to the given inequality? I want to apologize right off for my voice. I have a cold, but you know, you got to feed the beast. You got to post videos. So here we go. Okay, there's a couple different ways we can solve this. We can do this by graphing. We can do this just using, and we can do this with graphing using a graphing calculator. We could try to manually graph it. I do not recommend that, especially not on a timed test like the SAT. We also can do this with just straight math, which you can use with or without a calculator, but you don't have to graph it if you don't want to. So here's the graphing method first. When we plug this in, when we put y is greater than 13x minus 18, we're going to get a graph, and I am not drawing this to scale because it's going to be huge, that you're going to have a y-intercept that's going to be down here at 0, negative 18, and we know that from that negative 18. When you're graphing a inequality, if you're doing this by hand, it's just FYI, and so you know that you've that you've typed this correctly into your graphing calculator, you know what you should be seeing. You graph it just like a line to start with. So just like a line where it's y equals mx plus b, this b is your y-intercept, that m is your slope, the rise over run. So I'm sketching this out, I'm doing that same thing. I got my y-intercept there at negative 18, my slope is a positive 13, so rise over run, it's going to go up 13 towards the positive y, and then it's going to go to the right 1. So say this is negative 18, then going up 1 and over 13 would be like there somewhere. And a normal line would just go, you know, straight through them. This is an inequality though, and it's greater than. It is not greater than or equal to. The things that are on a line connecting those 2 points would be the equal to part, but it's not. It's just greater than. So what you do, if you're manually graphing this, and if you are graphing it on a computer, this is what you'll see. You'll see a dashed line. It's going to be a little, I drew, that slope is a little shallow. It's probably more steep, almost vertical, but just for the purpose of our quick sketch here. Again, I'm sick. I'm pleading that. Okay, so you're going to get this line. It's going to be going up to the right, very steep. It's going to be dashed. There's also going to be some shading on this graph. The shading tells every possible color ordered pair that will fit into this equation of y is greater than 13x minus 18. If you are doing this manually and the point 0, 0 is not on the line that you've started with, the way you figure out where to shade is you plug 0, 0, again, assuming it's not on the line, into your original equation, and you'll get 0 is greater than 13 times 0 is 0 minus 18. 0 is greater than negative 18. Is that true? Yes, it's true. then you shade where it's true. If 0, 0 makes true, you shade where 0, 0 is. If 0, 0 is false, you shade where it isn't. So when you put all this into your graphing calculator, you're going to get something that looks somewhat like this. Then what you would do is you would look at these possible options and you would see which of them has an ordered pair or 3 sets of ordered pairs that are all in that shaded area. Honestly, I think that's a little time consuming. It's made slightly faster by the fact that all of them have the same x's, 3, 5, and 8. And it's that quality that they're all 3, 5, and 8 that I honestly think just doing it with the help of your calculator is fine, but just doing it math-wise instead of graphing-wise is a little faster. Because here you'd have to look for, for 3. You'd find your 3 and you say, okay, at 21, is it in here? Is it down here? Where is it at? All right, at 5, 47. Is it there? Where's it at? 8, 86. Is it there? Where's it at? And you'd have to go through each one of these until you find the right answer. And it could be D. We don't know yet. So that could be a lot of searching on the graph. Now, what do I mean when I say do it just mathematically? What you would do, since again, all of these use the same 3, 5, and 8. You'd plug 3, 5, and 8 into this side and see what you get. So 13 times 3 minus 18, 13 times 5 minus 18, and 13 times 8 minus 18. And I'm going to zoom out a little bit and I'm going to move this over. There we go. There we go. So 13 times 3 minus 18, and if you want to do that on your calculator, that's fine. That's 39 minus 18, or 21. 13 times 5 minus 18 is 65, minus 18, which is going to be 47. And 13 times 8 is 104, and 104 minus 18 is 86. So those are our 3 numbers, what y would be if it was y equals. But we want where y is greater than that. So now I just need to look over on this side and see which of them has 3 numbers where each one is greater than these 3 that I've found. So here, 21, 47, 86, they all match. No, I don't want where they match. I want where it's equal. A is out. 26, 42, and 86. 26 is greater. 86 is the same. 42 is less than. Nope, that one's out. C, 16, 42, 41. No, that's less, and less. That's out. D better be our right answer. 26 is greater. Yes. 52 is greater. Yes. 91 is greater. Yes. And just to make sure we're on the same page, when I say is greater, I'm saying 26 is greater than 21, 52 is greater than 47, and 91 is greater than 86, because that's what corresponds to when I plugged in 3, 5, and 8. 3, 5, and 8. So D is my answer. If you're really good at finding all of those points over here, then, that may be the faster method for you. It really does come down to the things I always tell students are what makes the most sense to you, and then, what you can do right, what you can do correctly, where you can get the right answer, and then what's the fastest. So if this was the only way you felt comfortable that you would get the right answer, by all means, do it this way. If you're like, oh, I can do it both ways, but I think this way is faster, then do it that way. If you can do it both ways and you think this way is faster, do it that way. It's a personal call. That's why I try to present different ways, if there are different ways, to do a problem so that you can decide what makes the most sense to you, what's going to get you the right answer, and what's the fastest. But there we go. D is our answer because all 3 of those values of x, if you plug them into this equation, or if you look on this graph, in the equation, you're going to get these 3 values are all greater than. They all make this a true statement. If I put those in for the y, it makes a true statement. And if I were to look for all 3 of these ordered pairs, they would all be in this shaded area over here. I'd be able to find all those pairs. So that also means They are solutions. It is a true statement. D is our answer. Number 23. A certain town has an area of 4.36 square miles. What is the area in square yards of this town? 1 mile equals 1,760 yards. Apologize for my voice. I still have a cold. I still sound bad. We're soldiering on. Right, so first we need to just figure out what a square mile is, and we need to figure out how many square yards are in every square mile. So that's our plan of attack, is how many square yards are equal to 1 square mile. Then we take that number of how many square yards they are, and we're going to multiply by the number of square miles we have, which is 4.36, and that will give us our final answer. So when it says 4.36 square miles, does it mean, this is where I expect many students to make this understandable mistake, does it mean 4.36, 4.36, and it's on a square? It does not. It means we have a space, and then when you multiply the two sides of this space together, you get 4.36 square miles. So like, let's say it could be 2.4 and 2.9. Multiply those together, you get 4.36. That would be 4.36 square miles. Now, obviously in the real world, we know a town doesn't look like a rectangle. Towns are all over the place. So again, what are we saying in real world terms? Here's a good way to sort of visualize it. 1 square mile is 1 mile by 1 mile. So if I had 4.36 of those, there's a second one, there's a third one, there's a fourth one, and then there is one. This is going to be 1 by 0.36. That is 4.36 square miles, because each of these 1, 1, 1. So what it would be saying is, if I said that this blobby shape up here had an area of 4.36 square miles, I'm saying it has the same area as this perfectly apportioned shape as well. They are the same. That's what we mean when we're measuring this area. Okay, so if I take one of these squares, that is 1 mile by 1 mile, or 1 mile squared, I want to find out how many square yards it is. I need to replace each of those sides, each of those miles, with yards. So this mile is 1,760 yards. And this mile is 1,760 yards. I am trying so hard not to sniff and sound gross right now. You have no idea. All right, so if I multiply these two together, and yes, I absolutely wrote this down because I can't do that in my head. I like doing mental math, but even I have my limits. You get 97,600 square yards. That is the same as 1 square mile. And if you look at our answers over there, if you're paying attention to these little answers, you go, you probably already know what the answer is. Why do I say that? Because the first 3 are all less than 3,097,600 square yards. So if the answer is this number times 4.36, how could it be less than 3 million? It's impossible. So all 3, A, B, and C, that are less than are out. But it's always a good idea to follow through with the math, because we want to make sure we didn't make any mistakes. If I just at this point said, oh, well, obviously it's D, and I moved on without multiplying it by 4.36, it's possible that, maybe you make a mistake. You made a mistake multiplying. Type something in wrong into your calculator. And now you've just assumed and you moved on. So it's always a good idea to follow through, even though we're like, all right, I'm pretty sure it's D. I'm pretty sure it's D. So I'm going to erase, whoops, not right on it. I'm going to erase it. I'm going to erase this down here. So that's 3,097,600. I'm going to multiply that by 4.36 because it's 4.36 square miles. And again, I am not multiplying that longhand because I don't have to when we multiply that. we do in fact get exactly 13,505,536. Always good to know the process, always good to know what you're supposed to do at each step, even when, like in this case, they're helping you out by giving you only one answer that's really possible. They may not be so kind the next time. Honestly, I was really expecting a decoy answer here that was over 56 million, because that's what you get if you do that setup that I was talking about at the beginning, where it's 4.36, and you converted each of those into yards and multiplied them. You get about 56.2 million. I was really expecting that to be a decoy answer up there, and I think that would have trapped a lot of students, but they're being nice. So here our answer is D. Number 24. A square is inscribed in a circle. The radius of the circle is 20 square root of 2 over 2 inches. What is the side length in inches of the square? I always like to draw things, especially when we're talking about geometry. I love drawing it so I can see what I'm dealing with. Inscribed in a circle means I have a circle and there is a square, and all 4 points of the square are on the circle. That is what inscribed means. Okay, so the radius of the circle is 20 square root of 2 over 2 inches. The radius is, if I have a circle, it's a line that goes from the point in the middle, from the center, to a point on the edge. And it can be any point on the edge. The radius of the circle in any direction, it's always going to be the same. Well, if I have a square here, then the thing, since I'm trying to get to the side length of the square, that's my goal, to figure out any of these sides, how long are they? So how this radius reacts to or interacts with the square is what I need to be focused on. So what if I draw a line from the center to a corner of the square? And what if I can draw that accurately? There we go. Well, I'm trying. Let's go the other way. There we go. Okay, so I've just drawn a radius. It's going from the center of the circle, and it's also going to the edge of the circle. And it's on the circle, but it's also touching this square. So if I draw a second radius, I'm going to draw it the other direction with a different color. I've now made a diameter. Please forgive that it's not perfectly lined up. Yeah, I'm just freehanding with a stylus on a screen, so it's not perfect. Okay, so each of these radii is 20 square root of 2 over 2. So I have two of these. 20 square root of 2 over 2. So this length of this diameter, this diagonal of the square, it is both of those, is 20 square root of 2 over 2 times 2, because we have two of them. Now, 20 square root of 2 over 2, I say over 2, but it actually means divided by 2 when we're saying a fraction, when it's over 2. So if I divide something by 2 and then multiply it, that just undoes, right? I divide by 2, if I can write that correctly, divide by 2 and then multiply by 2, those cancel out. So that's what I've done here. 20 square root of 2 over 2 times 2. The over 2 times 2, they cancel out, and I'm just left with 20 square root of 2. Okay, I'm going to take this square out of the circle. I'm not going to really need the circle anymore. It has served its purpose. So I have the square, I've taken it out of the circle, and I know this across the length of it is 20 square root of 2, this diagonal. What happens when you draw a diagonal, as I hit my microphone with the stylus, what happens when you draw a diagonal through a square? I divide it into two triangles. Like that. Kind of like that. Oh, it bugs me. It bugs me when they're not drawn really well. I'm sorry about that. I'm going to try to draw it a little better. Wow, that was horrible. All right, I give up. All right, so I make two triangles. They both have 90-degree angles.
And because these over in the corners started as 90-degree angles when they were over here, and I'm splitting them in half, they are now 45-degree angles. So I've created two 45, 45, 90 right triangles. These are one of those patterns that they ask you to memorize. They do provide the formula for these and also for 30, 60, 90 right triangles. But if you have it in your head, it just saves you time. So for a 45, 45, 90 triangle, the pattern is you have the 90-degree angle, you got your 45 and your 45. The pattern, the way they usually write it is with A. I'm not sure why they picked A, but they did. Each of the two legs of the triangle, the two that are touching the right angle, are the same, and they're represented by this letter A. And the hypotenuse, the long side, the one that is opposite the right angle, is going to be A times the square root of 2. A square root of 2. I just saw that. Where did I see that? All right, so I have this. I'm creating this triangle, and I'm just going to highlight it inside here, and I've established this as a 45, 45, 90 triangle. Boop. And so this 20 square root of 2 is the same as my A square root of 2. It is the hypotenuse. So each of these sides, and that's the goal, the side length, that's what I'm going to. Each of those is A. So if 20 times the square root of 2 is equal to A times the square root of 2. We want to solve for A. I'm going to undo what's been done to A. I'm going to divide by the square root of 2 to get rid of it. I'm going to do that on both sides. And I am just left with, since this is 20 times the square root of 2 divided by square root of 2, they cancel out. A is 20. And that is the side length in inches of my square, and that is A, 20. Number 25, which expression is equivalent to y plus 12 over x minus 8 plus y times x minus 8 over x squared y minus 8xy? With these kind of problems, when they say which expression is equivalent, I always recommend looking at my answers first. Kind of know where I'm going. Sometimes you will see things being left in binomial form. Like there might be, see up here, we have a binomial y times x minus 8. And sometimes when you see that and you go down and you look at the answers, you'll see an x minus 8 somewhere still lingering in there. In which case you know, oh, okay, I don't need to multiply. I just need to leave that alone and do something else. That is not the case here. Every answer has things that are combined, distributed. There's no parentheses in sight. So we're going to get rid of those parentheses very quickly. Also, all four of these are a combined single fraction. So I know I'm going to have to figure out a way to combine these two by creating a common denominator between the two of them. The denominators, those bottom numbers, those bottom terms, those bottom polynomials, they have to be the same. All right, so on the left, I have my y plus 12 over x minus 8. And on the right, I have y times x minus 8. That 8 went crazy as my stylus jumped. There we go. Over x squared y minus 8xy. So I have two things I need to do. I need to simplify that, or distribute that, I should say. And then I need to make these two match. Okay, so how do I get from x minus 8 over to x squared y minus 8xy? Is there something I can just multiply x minus 8 by to get to that? We're going to look and we're going to see. It's one of those two things. You look at the one that's more complicated and you say, okay, can I take this simpler one and multiply it by something to get to the more complicated one? If that's possible, that's great. Another thing that may happen is there has to be one that kind of is in between, shall we say, where I have to multiply this by something and also multiply this by something to get to a common denominator. That's also possible. So I'm going to look at, because I see an x there and I see a minus 8 there, I'm like, maybe. If I were to say, is this x minus 8 times something? Could I pull something out to leave x minus 8 behind? Well, x squared times y, what would I multiply it by to get to x? I would need 1x. X times x is x squared, going backwards. And I would need a y, because y times 1, y times nothing is y. So x times xy would get me to x squared y. All right, does negative 8 times xy get me to negative 8xy? It does. So, okay, xy it is. I can pull xy out of this x squared y minus 8xy, leaves x minus 8 behind. So that means that I can just take that xy, multiply it over here, and then I'll have my common denominator. But is it just xy? Well, I can't change this. I can't change this fraction in any way, so I can't just multiply the bottom by xy. I also have to multiply the top by xy, because then I'm multiplying by 1. A number over itself, except for 0, is 1. So xy over xy is 1. I can multiply this fraction by xy over xy, and I'm not changing it. All right, so let's do that. First, xy times y plus 12. Again, we're setting it up. It's like parentheses, but there's no parentheses in the final answers, so we need to distribute this. First, xy times y, xy squared, y's get together. Xy times positive 12, 12xy. And on the bottom, we already know this is going to get us the same as the other side, x squared y minus 8xy. All right, I'm going to write that again over here, x squared y minus 8xy. Now on the top, I want to distribute. Y times x is yx or xy. We put those x's first. Y times negative 8 is negative 8y. Now that I have common denominators, I can combine everything on top. This is behaving just like those fractions you learned so long ago in elementary school. Things like 1/3 plus 1/3. How many thirds do I have? I have 2 thirds. So you add the numbers on top, the bottom stays the same, because that's what it's saying. It's not saying we add the numbers on top, we add them on the bottom. No, it's saying I have 1 of a third. I have 1/3 of a thing. And I have another third of a thing. So now I have 2/3 of the thing. So in this case, it's like I have xy squared plus 12xy of x squared y minus 8xy's. And I want to add xy minus 8y of x squared y minus 8xy. How many x squared y minus 8xy's do I have? That kind of thing. So we combine all those terms on top. We see if there's any common terms, any like terms that we can add. So we have xy squared plus 12xy plus xy minus 8y all over x squared y minus 8xy. One thing to be mindful of, this is a plus, which makes it nice and simple for us. If this were a minus, always remember it applies to everything, so change the signs on everything. Just a little tip there, because they like to throw those in. Okay, there's only one xy squared, so it doesn't change. It just stays xy squared. Then 12xy and 1xy. How many xy's do I have? I have 13 xy's. And then that minus 8y, it just stays the same. You have that x squared y minus 8xy on the bottom. Now, and so xy squared plus 13xy minus 8y over x squared y minus 8xy, and that is C. Now I'm going to zoom in on those answers. If you look at this, you see how this is the only one that has x squared y minus 8xy. So it is reasonable, once you get to the point where you know that that's the common denominator is going to be x squared y minus 8xy. That is a reasonable assumption that this is the answer at that point. given our other answers. Why do I say given the other answers? Because it is possible, we already know that xy times x minus 8, you can pull that xy out. There are problems where after you combine them, that you might realize, oh, I can pull an xy out of the top and an xy out of the bottom, and then they cancel out so I can simplify it. So if you saw any other answers here that were simpler, that looked like they had pulled that xy out and it was just an x minus 8, they would be in the running, and you need to take a look at them too, and you'd need to just keep going on with the problem. But yeah, sometimes with those multiple choice answers, you go, wait a minute, is it just C because it's got that denominator? Yeah, in this case, it really is. None of the others are possible. They're really kind of honing in on your ability to find that common denominator and what you do with it. Some of these are going to be like they multiplied those together. Yeah, that's what's going on with some of these other, the other answers. However, I don't like to just say, I don't want to just stop halfway through this problem, because you're like, wait a minute, Alyssa, you can just look over there and you can see it. You don't have to go through the thing of adding them together and combining the like terms. Why did you do that? I did that because they're not always nice. They don't always give you this nice little one where it's the only one that would work. So you need to know how to be able to keep going through the problem and complete it. So even when you get one with some more reasonable options, that you know how to find the complete answer. But yep, in this case, it is C.
Number 26. The function f is defined by f of x equals a times 2.2 to the power of x plus 2.2 to the power of b, where a and b are integer constants, and 0 is less than a is less than b. The functions g and h are equivalent to function f, where k and m are constants. Which of the following equations displays the y-coordinate of the y-intercept of the graph of y equals f of x in the xy plane as a constant or coefficient? Boy, do they love this type of problem. It shows up a lot, and I think they like it because it confuses students, frankly. It's this part, which displays this as a constant or a coefficient, and it's a phrasing and it's a type of problem I'm going to bet you haven't seen in your classroom or in your math book, so it can be very kind of off-putting and just like, and you don't know where to go from it. I totally get it. I understand. All right, so let's break this down, what we're presented with, what we can do, what we can't do, and what they are actually asking. So back to the beginning. The function f is defined by, and I'm going to write it over here, f of x equals a times 2.2 to the power of x plus 2.2 to the power of, got ahead of myself with that parentheses, the power of b. All right, so far so good. Now our a and b variables, we know x is a variable because we have f of x, means whatever I put in for x, I do the math, I get an output, and that is my f of x or my y value if I'm graphing it. A and b, we might look at it and think they're variables, but they're not. We're told they are integer constants, and a is greater than 0, and then b is greater than a. They're not telling you this for you to solve for a and b. That's not possible. It's not. To solve for multiple variables and figure out what constants they represent in an equation, you need as many equations as you have variables. So if you have 2 variables, you need at least 2 different equations. If you have 3 variables, you need at least 3 different equations. It's just the way it works. I'm trying to think of an exception to that rule. If there is one, please leave it in the comments below. I would honestly love to hear it. I love learning new things, but I can't think of any. So for this, you can't solve it. You would have an a, an x, and a b, and you've only got this one equation. You're like, oh, I've got these 2 down here. Not really. We're told they are equivalent. G and H are equivalent. So they're all the same equation. The only thing that this 0 is less than a is less than b, the only reason it's important is it's telling us that neither a nor b is 0. So a does not equal 0 and b does not equal 0. We also know they're both positive because they're both greater than 0 and they're integer constants. A is smaller, b is bigger. So the smallest possible would be a is 1 and b is 2, but it can go up from there. It could be a is 1 and b is 1,000,000. We don't know. But this right here, that neither of them is 0, is going to be the key takeaway from that. All right, let's move on to the next bit. G and H are equivalent to F, so they are the same thing. They're just written a little differently. Okay, so first we have G of X equals A times 2.2 to the power of X plus K. Now, because these are equal, I can start to set up some equivalents here, right? They're the same thing. So I could say they are equal to each other. A times 2.2 to the power of X plus 2.2 to the power of B is equal to, and I'm going to have to back up so I can give myself plenty of room for this one, is equal to A times 2.2 to the power of X plus K. Well, I've got some things that I can state are equivalent because of this. Now, some of you might just be able to look at it and see what's equivalent in that equation. If so, that's great. If you can't see that, that's fine too. Don't worry about it. We're going to go through it step by step so you can see where the equivalence is. All right, so first, I have this A out in front on both of them. A is being multiplied by this whole thing. I'm going to divide both sides by A. That leaves me with 2.2 to the power of X plus 2.2 to the power of B on the left and 2.2 to the power of X plus K on the right. Now, since that 2.2 to the power of X is being added, I'm going to subtract it on both sides. That cancels out on both of those sides, and I am left with 2.2 to the power of B is equal to K. All right, so that's a good fact to know. I'm going to write it over here. 2.2 to the power of B is equal to K. And I don't know yet what's going to come in handy. I'm just trying to get everything I can for the next part of this. I want to know everything that I can. All right, so that's the information I gleaned by comparing those two equations. Let's go back in for h of x. I'm going to pick a different color here. Let's just go dark blue. All right, so h of x is equal to a times 2.2 to the power of x plus m. All right, so in order to compare these now, I'm going to need to distribute. And I'm going to compare these two right here. So if first I have that f of x, and if I am distributing it, I'm going to get a times 2.2 to the power of x plus a times 2.2. I'm running out of room. Let's zoom out so you all can actually see what I'm doing. A times 2.2 to the power of b. Okay, so I've distributed that. And over here with this h of x, I'm going to write it a little lower and then write the distributed above it. A.2 times 2 to the power of x plus m. Now this little to the power of x being on the outside, it doesn't matter if it's on the outside. Random ruler out of nowhere. I love doing that when I'm trying to erase things. It doesn't matter if it's on the outside or if it's on the inside. They're just messing with you. So a times 2.2 to the power of x. To be clear, it doesn't matter in this particular situation when it's a single letter and then you have that x there. If there was anything else inside that parentheses along with the 2.2, we'd be having a different conversation. But just the single constant, it does not matter if the exponent is inside or outside when that's the scenario. Okay, so a times 2.2 to the power of x, a times 2.2 to the power of x. So I just distributed that. And then I have my plus m. Okay, so same sort of thing. I'm going to see what's equivalent by subtracting, getting rid of things that are the same. So I'm going to subtract a times 2.2 to the power of x on both sides. They cancel out. And I am left with m is equal to a times 2.2 to the power of b. All right, so that's another thing I'm going to write over here on the side, that a times 2.2 to the power of b is equal to m. Okay. So what's like one more thing that I could figure out from what I have right here? If 2.2 to the power of b is k, and a times 2.2 to the power of b is m, I can say, since k is the same as this, I could also say a times k is equal to m. All right, so those are all the things that I can see. What does k represent? What does m represent? And why does it matter what k and m are? The reason this matters, the reason I'm doing this, is this final question where it says, which of these equations shows the y-coordinate of the y-intercept? That'll be our next point. I'm getting there, I promise. Which one of them shows this number as a constant or coefficient? So in g of x and h of x, these a's out front are constants and coefficients. They're both. They are constants. They're not changing. We're told a is a constant. And they're coefficients in that they are multiplying by this number, 2.2 to the power of x, and the other one 2.2x plus k. Okay, so a would be one of the contenders that might fulfill their answer to their question. K is another constant. M is another one. So they're wanting us to figure out what a potential y-intercept would be, and is it possible that that y-intercept would be a, k, or m? That's why I did all this, because I'm trying to figure out how can I relate them to each other, a, k, and m. What are a, k, and m equal to? Because they're wanting me to graph f of x and find out what the potential y-intercept would be. What is a y-intercept? A y-intercept is where a function, any function, a line, a parabola, a cubic, whatever it is, so many functions, whatever it is where that function crosses the y-axis. So all y-intercepts have one thing in common. The x value is 0. Always. It's going to be 0, comma, something. Wherever it crosses, x is 0. So if I were to plug 0 into this equation and do the math, I will get a representation. It's going to have a's and b's in it, of course, but it will be a representation of what the y-intercept is going to be. All right, so let's do that. Let me plug in 0. All right, so f of x equals a times 2.2 to the power of 0 plus 2.2 to the power of b. Okay. So a times 2.2 to the power of 0 plus 2.2 to the power of b. What is 2.2 to the power of 0? Any number besides 0 to the power of 0 is 1. So a times 1 plus 2.2 to the power of b. So my y-intercept is going to be a times 1 plus 2.2 to the power of b. Is this ever going to be 0? No, because a is not 0. This is never going to be 0. It's always going to be a positive number because a and b are both positive. A will be at the minimum 1. B will be at the minimum 2, and it's going to go up from there. This will never be 0. It will never be negative. It's going to be 1 times, at the least, 1 times 1 plus 2.2 squared. As the smallest possible number it's going to be. In that scenario, 1 times 1 plus 2.2 squared. What would that be? 2.2 squared is 4.84. So it would be 1 times 1 plus 4.84. Okay, so again, here's our scenario. 1 times 1 plus 4.84 is 5.84. 1 times that is 5.84. So when A is 1 and B is 2, then my y-intercept, the y value of that y-intercept is 5.84. Would 5.84 show up anywhere in here? Would it be a constant or coefficient? Is that even possible? Well, let's see. A, we already know what A would be in this scenario. It would be 1. That is not 5.84. And remember, the only ones we're looking for are A, K, and M. Could A, K, or M be 5.84? Well, we're told up here, we figured out that K is 2.2 to the power of B. 2.2, when B is 2 in our scenario, 2.2 squared is 4.84, not 5.84, because we added that 1. That little 1 got added to it, and it bumped it up from 4.84. And we can see that that's going to happen. Like if we go back to the original, we don't even have to look at our little chart down there. If you really want to see it, you can say here, okay, then a is 1. It's 2.2 to the power of 0 plus k, and it has to equal 5.84. It's going to be 1 times 1 plus k equals 5.84. So I would have to subtract 1 from both sides to solve for k. K is 4.84. That's just further confirmation. K cannot be 4.84 because 1 is being added to it first. That's never not going to be true because it's a number line, right? Think of a number line. If k is here, something's getting added to it, and we know that something is always going to be positive. Always. It's going to move up. K will never be the same as something. You cannot add a positive number to something and have it not change. It only stays the same if we add 0, and we know a and b are not 0. All right, let's look at h. Is it possible that m could be equal to 5.84? Let's back it up so we can really see everything here. Again, m is a times k. Well, in this case, a is 1, and k is, we already established in our scenario, 4.84. So m would also be 4.84. It's never going to be 5.84. It's always going to be smaller because we're adding things to it every single time. So none of them, a, k, and m, can never be the y-intercept because things are always being added to them to get to the y-intercept. So our answer is going to be D, neither 1 nor 2. Now, just to kind of give you guys a graphical representation, like if you wanted to figure this out using Desmos, that's totally possible too. So let's go over to Desmos. All right, so here's our original f of x. A is 2.2 to the power of x plus 2.2b. I have my sliders. So you absolutely can set this up and start going, okay, well, what if a is 2? And if I can get it to line up, and then b has to be a constant bigger than that, so I'll make it just 3. All right, well, then what happens? Then it's 23.296. Well, okay, what does that make everything? Well, I've already got it set up. You don't have to wonder. There's my with 1 and 2. Well, here's where the 2 and 3. F, G, and H. I've already plugged the numbers in for you. So, okay, we're following their form. There's my 2 out front times 2.2 to the power of x plus 2.2 to the power of 3. See, it's the same as that first one here. I just moved it down a little bit. 0, 23.296, just to show you I typed everything in correctly. 0 and 23.296. And there's our g of x with my k. So I know I figured out that k is equal to 2.2 to the power of b. My b here is 3. 2.2 cubed is 10.648. And so now you can see there the green is lining right up on top of the red. So there's the red, there's the green. Yep, they are the same, just like they told us they were. And there my k is 10.648. My y-intercept is 23.296. They're not going to line up. Why? Because that k has something added to it, and in this case it's being multiplied by 2. Makes it even bigger. The difference is even greater. And then finally, what about h? Well, here, that 21.296 comes out to the outside, because that's a times k is our m. So 2 times 10.648 becomes our m there. It's still not going to be the same as the y-intercept because we're adding this here, and this is never going to be 0. Something's being added to it, and it's never going to be 0 added to it, so it just cannot ever, a, k, or m, none of them can ever be the y-intercept, because the y-intercept is created by combining those constants together, and none of them are 0. Okay, this is a very conceptual one. It's not, like I said, it's not something you're going to see in your math book. I really doubt it. But boy, oh boy, do they love those ones where they say, can you find this as a constant or coefficient? And all of these are equivalent. And they can just be paralyzing for students because if they've never seen ones like that before. So yeah, look around in the practice tests, find the ones like these that have that, look for that, have it as a constant or coefficient. I know I have some of them posted on my channel from the different tests. If you come across them, practice them, get used to it, because especially if you're going for those really high scores and you want to make sure you know everything they can throw at you, this is definitely something they can throw at you. Number 27. X times kx minus 56 equals negative 16. In the given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? Okay, an integer constant just means a number. An integer is any number that we think of like, it's not a fraction, it's not a decimal, it's like -5, 22, 0. These are all integers. There's no decimal after them, there's no fraction, no square roots, nothing like that going on. It can be positive, it can be negative, it can be 0. That's an integer. Constant means it doesn't change. So just a number, and it's not a decimal or a fraction. Now, it has no real solution. When we're talking about no real solutions, if we're talking about that graphically, we're meaning that if whatever number I put in there for k, the resulting graph will not cross the x-axis. Those are the solutions. So like if it's a line, that'd be considered a solution. If it's a parabola, be no solutions, one solution, two solutions. Because it doesn't touch it, touches it once, touches it twice. That's graphically. If we're talking about this mathematically, it means a number I can put in here for x to make this true. So first, I see when I multiply this, I'm going to get an x squared. So this is a parabola. Right off the bat, it's a parabola. And there is a way with parabolas and with the quadratic formula, the formula we use to solve quadratic equations, that can tell us when there's no solution. So that's immediately where my mind is going. First, I want to turn this into a more recognizable quadratic equation. So to do that, I'm going to multiply these things on the left and distribute them, get it all looking more normal for a quadratic equation. First, x times kx is kx squared. Then x times negative 56 is negative 56x. And that equals negative 16. Now I mentioned the quadratic formula. And that is saying that when I have a quadratic that is in the form of ax squared plus bx plus c equals 0. That part's important. It has to equal 0. And a, b, and c are constants. They are numbers. That if I have a quadratic in that form, I can solve for x like this. X will be equal to negative, or the opposite of, the b value plus or minus the square root of the b value squared minus 4 times a times c, those values, all over, and I keep writing too big and running out of room, all over 2a. So I'm close to being in that form up here in the green on the right, but not quite. It's not equal to 0. To make it equal to 0, I want to move this over. To move it over, I'm going to do the opposite. Since it's a minus 16 or negative, I'm going to add 16 to both sides. So on the left-hand side, I get kx squared minus 56, I wrote 5x, 56x plus 16, and then minus 16 plus 16 is just 0. All right, now it is in this form, ax squared plus bx plus c. In this quadratic formula, there is one part, one little subset of it, that determines how many solutions there are. And it's this bit right here under the square root. Why would that determine things? Well, what happens if I take the square root of a positive number, like the square root of 4? The square root of 4 is either a positive 2 or a negative 2. Two possibilities. What if it's the square root of 0? Well, that's just 0, right? One possibility. What if it's the square root of a negative number, like negative 1? There's no possibilities. There is no real solution. So that's what determines it. If this b squared minus 4ac, the bit under the square root, is a positive number, you will have two solutions to that quadratic. If it turns out to be 0, you have one solution. If it turns out to be negative, you don't have any solutions. So that little piece, that b squared minus 4ac, it has a fancy name. It's called the discriminant. And I really hope I'm spelling this right. Discriminant. Now, to be clear, this is why I'm going through all this in great detail, is because these two things, the quadratic formula, and the discriminant, they are not included in that little chart at the beginning of the section where they give you a lot of the formulas for volume, area, special triangles, things like that. This is not in there, and yet it does come up on the SAT. That's why I'm taking a second to go through it, because especially if you're aiming for those, those high scores and you want these, these are the higher number questions, they get harder as it goes. If you're wanting to get those right, this is one of the pieces of information I recommend knowing. Okay, so we don't have to look at this whole thing to determine how to do this with the equation having no real solutions. All we need is that discriminant, b squared minus 4ac. So, okay. So you're like, Lissa, why did you do that then? Why did you tell us all this if we didn't need that? Well, you need it for other things, and plus I think it's helpful to know where it came from, so I'm not just telling you, pull random numbers out of thin air and it will tell you this magical answer. There's a reason. There's always a reason in math, right? Yeah. Right, so the discriminant is b squared minus 4ac, and we want this to have no real solution, so it needs to be negative. How would I set this up? I want b squared minus 4ac to be negative. Another way of saying that in equation form is less than 0. So I am going to plug my b's, a's, and c's from up here. There's my a, there's my b, include the negative with it. There's my c, include the positive with it. Now plug them in here, and I'm going to solve this equation. So first, my b. My b is negative 56. I'm going to square that. And then I'm going to subtract 4 times my a is k, positive k, and my c is 16. And this all needs to be less than 0. And my chairs are really squeaking today, and if you can hear that, I apologize. I need some WD-40. So I'm going to bring this up here. So negative 56 squared, I wrote it down because, no, I can't do that one in my head, is 3,136 minus 4 times k times 16. I'll do 4 times 16 is 64, 64k, so minus 64k is less than 0. Now I have a pretty straightforward algebra problem that I can solve. First, I am going to get rid of that 3,136. I'm going to subtract it from both sides to get rid of it and end up with negative 64k is less than, make sure that k is connected so it doesn't look like another less than, is less than negative 3,136. And now I want to divide both sides by negative 64 because that's undoing what's been done to k. K is being multiplied by negative 64. So I'm going to divide by negative 64. Right, so when I divide this, I get 49 on the right, and I get k. What is the sign in the middle? Anytime we divide or multiply by a negative when we're solving inequalities, we reverse the sign. So important to do that. Critical to do that. You have to. And if you're wondering why that happens, like why would you reverse it? I'm going to do this as a little aside right here, and then we'll come back to the main thing. I want you to understand things. I know I over-explain sometimes, but I really want you to understand these math concepts, to know what's going on and not just memorize rules. Let's go back to this step right here. 3136 minus 64k is less than 0. What would have happened if instead of getting rid of the 3136, what if I had dealt with the negative 64k? What if I added 64k to both sides? Then I would have had 3136 is less than, I wrote 64.6, sorry about that, 64k. I would divide both sides by 64, going through this quickly, and I would have got to 49 is less than k. Look at that. It's saying 49 is less than k, or k is greater than 49. That big mouth of the crocodile is pointing towards the k, and look at what's happening over here. big mouth of the crocodile. I don't know if you heard that in elementary school. That's how our teachers taught us. The crocodile eats the bigger number. The big mouth of the crocodile is pointed towards the K. That's why we reverse it, because if we just added it, the K would have moved to the other side. It would have been on the other side. That's what's going on. Little digression. If that wasn't helpful, I apologize. But hopefully that'll help you remember when you divide by that negative and in an inequality, you reverse it. So K is greater than 49. Does that mean 49 is my answer? No, it doesn't. Why not? Because it says, what is the least possible value of K? Could K be 49? It could not. It is not. K is greater than or equal to 49. Nope. K has to be greater than 49. And we know it is an integer constant. It's one of those numbers on a number line. So it is 50. One last final thought is, if you didn't know about this whole thing where it changes direction when you divide by a negative, you would have known something was up when you got to, you would have seen it as K is less than 49. And then when it says, what is the least possible value of K? Well, K is less than 49. Think about it like on a number line. If you're here at 49 and it's less than, what's the least possible number? That's infinity. So you would have realized something was up at that moment. It would have been like, what's going on? But that's some valuable time trying to figure out what's gone wrong and having to work back and figure it out. And, it's always easier if we just have that information in our head immediately for access. So I know that was a bit of a long explanation. I added some extra stuff in there. I hope it was helpful and not just extraneous info that you were skipping past. But the answer is 50. And congratulations, you have finished this section of this practice test. Hey guys, this video was helpful or useful in any way. Please feel free to let the algorithm know about it. Like, share, comment, subscribe, even buy me a coffee if you're so inclined. Links for that down below as well. Thank you so much for stopping by. I hope you have a great day. See you later. Bye.